So far the examples we've done have been square roots. Now let's look at some cube roots. So you notice this number here, that 3, and this 3 here, just kind of like sitting right above the little radical symbol. That is called the index of the radical. So this will be an index 3 radical. And again, if you don't see that number there, it's understood to just be 2 because square roots happen so often. So what you're looking for here is, are there any perfect cubes underneath the radical symbol? Let's do this one first. The cube root of negative 1,000. Well, I know that 10 cubed is 1,000. So remember, 10 cubed, that's 1,000. So 1,000 is a perfect cube. But what about this negative? Well, let's see. What is negative 10 times negative 10 times negative 10? Well, negative times negative is positive, times a negative again, you do get negative 1,000. So if you have an odd index radical, that's going to be negative. It's going to be a negative number. So the cube root of negative 1,000 is going to be negative 10, because negative 10 cubed gives us negative 1,000. Okay. Let's do the same thing over here with the cube root of 54, x to the 5th, y to the 6th. All right, so first of all, 54. Let's see if there's a perfect cube in the number 54. Well, let's see. 54 is an even number, so I know that 2 is a factor, and 2 goes into 54 27 times. 27 is a perfect cube number. Again, if you remember, we've got this list of small perfect cubes. 3 cubed is 27. All right, so let's break this down. Now that we recognize that 27, this perfect cube number, is a factor of 54. Just like with our square roots, we're going to think of this as the cube root of 54, and then times the cube root of x to the 5th, times the cube root of y to the 6th. And let's do each one of those separately. So the cube root of 54, that'll be, 54 is 2 times 27, so I think of that as the cube root of 2 times 27. The 27 can pop out front because the cube root of 27 is 3. So this becomes 3 times the cube root of 2. Okay, so that's that part. Let's look at the cube root of x to the 5th now. Let's see if there's a perfect cube in x to the 5th. X to the 5th can be thought of as x cubed times x squared. That's a perfect cube. Cube root of x cubed is just x, so it becomes x times what's left underneath is x squared. Now let's do the cube root of y to the 6th. So again, y to the 6th is a perfect cube because y squared, this is how I like to think of it, y squared cubed does give us y to the 6th. So this should become y squared. Here's another way to think of it too. I could think of it as the cube root of y cubed times y cubed, right? Y cubed times y to the 6th. So then a y pops out, and then another y pops out. So what I'm left with is 2 factors of y. All right, so now I've simplified each one of the factors underneath the big radical symbol. So now I'll just put it all together by grouping all the factors outside the radical and grouping all the factors inside the radical. So I got 3 times x times y squared. All of that times the cube root of what's left underneath, 2x squared.